All right, so let's think about one thing. The first things first is we always look at this as like 360 degrees, 90, 90, and if it's going in a positive direction or negative direction. In this case, it's going up, so that's positive 90, then 180, 270, and 360. Right? Did I push record? Hopefully. Yep. Okay, so then we want to look at, okay, I go around one time. That's 360. I know that I have 360 already because I went around one full time. Then I went around a half. That's 180. So that's 180 more. Now I want to know how far did I go here? Well, if this is 90, right? But this is 70, then what's left is 20, right? 90, 70, 20. So once I know that this is 20, then I have 20 more to go. So when I add all this up, I have 200 plus 360 is 560. So this is 560 degrees. Okay? Now, same thing. This is 2 pi. This is pi. Okay? So when we're talking about radians, everything's in pi and 2 pi. Now, right here, we're talking about 6 over 6, right? So how do I make 2 pi? Well, that would be 12 pi over 6, right? And this would be 6 pi over 6, right? Because it's just 1 pi. So 6 pieces, right? Which means I have 3 pieces, 3 pieces, 3 pieces, and then 1 more piece. So 3 plus 3 plus 3 plus 1, 10 pi over 6. Okay? Now we can reduce that, right? And get 5 pi over 3. Okay? Now I don't know what they're going to do. I can look at my answer here in the back. And number 2 is 5 pi over 3. So they did reduce it. Okay? But that's how you do that. You kind of just always just take whatever they're giving you in the radians and just know, hey, 2 pi is going to be 2 of whatever the diameter is. Or, I mean, the denominator. I mean, they could give you 11. It doesn't matter. Right? If they say it's pi over 11, right? That's a tough one. It's like, what the hell are they talking about? Pi over 11. That's the weirdest thing I've ever heard of. It doesn't matter. Because I know that this is 22 pi over 11. Right? And if that's 22 pi over 11, then this is 11 pi over 11. Right? And if that's 11 pi, then this has to be 5.5 pi. Right? This has to be 5.5 pi. This has to be 5.5 pi. Right? So it's 5 plus 5 plus 5, which is 15, plus half, 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 which is 1, 16 and a half, plus 1 more, 17 and 1/2 pi. Done, son. I mean, that's a hard way of looking at it. I don't think they'll have one that hard, but that's the easiest way to think about it. Okay? Is always just break it down into how many pies you have. Okay? Radians were hard for me when I was your age, so I get where you guys are coming from, but I'm really trying to explain it so that you get it. Like, it's just pieces of pie. The problem is the pie is only halfway. It's not like you think of a pie as being a whole piece of, circle. So, but you have to remember that a pi is only half the circle. 2 pi is the whole circle. Yeah.
What if the pi is smaller than the number? 5 pi over 4.
So again, even if they have something like 5 pi over 12, right? And is that going up or down? See, that's going down. So they're saying that many. Okay? You got to remember, this is 12 pi over 12. Right? To get all the way over to here. Right? So how many pi's are in each piece?
12.
No, 12 in the whole. 6. 6 and 6. So if 5 are here, then how many are left? 5 are here, how many's left? 1. So it's just pi over 12. That's it. Does that make sense? So you just break it down into pieces. Okay? Whatever this diameter, this denominator is, that's how many pieces there are in your half circle. There's twice as many pieces in your whole circle. Okay? And then you just see how many pieces you have. How many pieces of pi you have. That's it. It's a fraction. That's all radians are. Is a fraction of a whole. That's it. Okay? Like I said, they made it so difficult in high school for me. To me, this isn't that hard.